Welcome to Yangel's algorithm series for absolute beginners. In today's video, we are going to learn about shell sort. It's a sorting algorithm that looks like a variant of insertion sort. Let's say you have an input containing numbers in random order and you are asked to write a program to sort it in ascending or descending order. Then you can use shell sort algorithm to perform this task. The core working principle of shell sort algorithm is same as the insertion sort algorithm. The way we assign input and process the output is what differentiates shell sort from insertion sort. Let's visualize the core principle of shell sort using the same visualization which we used for insertion sort algorithm. The core of our algorithm performs two functions. It compares the input value and it switches them if necessary. Let's try to understand the logic behind how shell sort works. We divide the input list into a number of sublists. We'll see how we can divide the input list in a minute. We then send the sublist into our engine one by one, where insertion sort is performed on each and every one of them. These sorted sublists are then combined into a single output. This semi-sorted output then becomes the input, and we continue this entire process all over again till the input cannot be divided any further. Now let's see the strategy which we employ to divide our input. To divide our input list into numerous sublists, we start fetching values from our input list. Starting at index 0, we select the values at constant interval along the input list. This interval, or gap as it would be referred from now on, is calculated by dividing the length of our input list by 2. And for our sample input, this value stands at 2. Now that we have determined the gap with which we are going to create our sublist from our input list, let's start dividing our input list. We start off at index 0 and fetch every second value as we move along the input list. Now we perform all the operations on these selected values. We perform a insertion sort on this sublist. We compare the first two values and switch them if necessary. Our sublist right now has a sorted section. All the unsorted values in our sublist will be inserted one by one into our sorted section, and the entire operation will be carried out all over again to find its rightful spot within the sorted section. This is an insertion sort after all, remember? Let's see our insertion sort in action. After the completion of insertion sort, we have a sublist that is sorted. We paste the sorted data back into our output list at the proper index. Let's do a quick recap on what we have done so far. We started off with an input list. We calculated a gap from the length of our input list. First, we fetched values from the input list based on the calculated gap starting at the 0th index. We then proceed to perform insertion sort on this sublist. Once the insertion sort has been completed, we pasted the sorted data back into our output list at their respective index. It seems we still have some unsorted data in our input list as highlighted. So we create a second sublist, this time starting at index 1. We fetch values that are two indices apart from each other. Thus we construct our second sublist and perform insertion sort on it. We perform the usual compare and switch operation to sort them in ascending order. Once the sublist has been sorted, we paste the values back into our output list at their respective index. Let's do a quick recap. We constructed a new sublist starting at index 1. We performed insertion sort on this new sublist and then pasted them back into our output list at the respective index. So, when an input is provided to us, we first compute the gap from the length of our input. Based on this constructed gap value, we produce a number of sublists. We then perform insertion sort on each of these sublists. We then combine the sorted sublist into an output list. Well, it seems our output is not yet sorted. Let's fix it, shall we? We perform these same operations all over again on our output. So our output becomes our new input. The difference this time being, we change the gap value. The gap value during our last operation was calculated to be 2. So this time we take the same value and then further divide it by 2. which gives us a value of 1. Notice how we are systematically reducing the gap value during each iteration. So when we start creating our sublist based on this gap value, starting at index 0, we find that it pretty much covers the entire input list. So whenever our gap reaches 1, our entire input list will be considered as our sublist, and we perform insertion sort on it. Now this is a typical insertion sort which you're seeing on the screen right now. First we sort the first two values of our input, and then we insert the remaining values one by one and find its location within the sorted section. As you might have noticed, after every insertion, our sorted section is getting bigger. This process continues until we have inserted every value into our sorted section. It seems we are going to perform the final lap of our insertion sort. Look at how the compare and switch operation is helping us to find the rightful spot of the inserted value within our list. After we perform compare and switch operation on each pair of values within the list, we are greeted with a sorted output list. As we have seen, shell sort is nothing but insertion sort done differently. By the time when the calculated gap reaches 1, we can be fairly certain that our input list would have been sorted. Now let's explore the code, shall we? This is a common textbook implementation of shell sort algorithm. When we provide this program with an input list to be sorted, the first thing which we do is we calculate the gap with which we are going to divide the input list into sublists. Do remember, the gap value which we have computed so far is valid only for the first iteration. We still have to go through a lot of iterations until the gap value reaches 1. When it reaches 1, the input list would be sorted. First, we check if the calculated gap value is greater than 0. We are doing this because when the gap value reaches 1, we are certain that our input list has been sorted. Next, we create a list in the memory of our program with values ranging from the gap value to the length of our input list itself. We then loop through each and every one of these. The highlighted code then starts an entire new loop. This loop will continue to execute as long as the operations within the list doesn't go beyond the list's either extremes. If this condition is met, we move inside the loop. This is where the compare and switch operation happens. The comparison happens between the values at the specified index and the value which resides at a distance of gap from our specified index. After the comparison, we switch their values if necessary. So essentially what we have done here is we have taken a sublist from our input list and we have sorted it in ascending order and we have pasted it back into our input list. The sublist which was just sorted right now can be viewed on the right side of your screen. We then proceed to check if there are any other values which we can insert into this sorted sublist to perform an insertion sort. Obviously, we will be checking at an interval that corresponds to the calculated gap value. When there are no further values at the desired interval, we just move on to the next iteration. We proceed to create a sublist with values at index 3 and the value at the specified interval. We then perform an insertion sort on this sublist. Remember, shell sort is just a collection of insertion sorts. We check if there are any insertion sorts which we can perform on this sublist. If not, we move on to the next iteration. We create a sublist and we perform insertion sort on their values. Then we move on to check if there are any other values which we can insert into our sorted sublist to perform insertion sort. Well, it seems we do have a value at the specified interval. We then perform a compare and switch operation between these values. Once we have completed all the iterations for the calculated gap value, we then move on to reduce the gap value. We continue this process until we have reached a gap value of 1. Remember, when the gap value reaches 1, it points to a pure insertion sort. We don't have to create sublists anymore. We can perform a pure insertion sort on our partially sorted input list. Once this is over, we would have a perfectly sorted output list. The program tries to reduce the gap value further, and when it falls below 0, the program terminates. There we have it. We have successfully used shell sort algorithm to sort our input list. See you guys in the next video. If you guys like our work, consider subscribing to our YouTube channel for more educational content.